Hello, everyone, and welcome. My name is Rula Deeb. I'm a senior principal at Geosyntac in Oakland, California, and the coordinator of the webinar series on behalf of SERDP and ESTCP. Today's webinar will consist of a brief overview of both programs, followed by a technical presentation featuring DoD-funded research efforts on advanced controls and energy management strategies for improving building efficiency. The technical content will be presented by three speakers: Mr. Dave Vigliotta from Slipstream, Dr. Joe Joe, also from Slipstream, and Mr. Guideline from TRC. We will break midway through the webinar to take questions from you, and we will conclude with a longer Q&A session. The next several slides provide instructions on optimizing your webinar experience. If you have not done so already, download Zoom at the link shown here and provide it to you in your webinar registration confirmation email. If you cannot download Zoom, you may view the slides using a compatible internet browser such as Firefox, IE, or Edge, and by creating a free Zoom account. If you are unable to view the slides or if your screen freezes, please try keying in Control and F5, and this will help you to perform a hard refresh. If you are accessing the audio through your computer, click the arrow next to the Join Audio button, select Test Speaker and Microphone, and follow the prompts as they appear on your screen. If you continue to have difficulties, please call into the conference line shown here. You may also submit a comment using the chat box. Please use the chat box only for comments related to technical difficulties. The Q&A option should be reserved for questions for our speakers. And in case of continued technical difficulties, feel free to download a PDF of the slides from the webinar webpage and call into the conference line provided to you in your webinar registration confirmation email. We will also be live streaming the webinar on the SERDP and ESTCP YouTube channel at the link shown on slide 8. Today's broadcast will be listen only. Please submit your questions using the Q&A box on your screen. Again, not the chat box, the Q&A box, please. You do not need to wait until the Q&A period to submit your questions. In fact, we do encourage you to submit them well in advance of these sessions. And when you do submit your questions, just add your organization name at the end of your question so that we can identify it during the Q&A sessions. With that, I would like to introduce Mr. Timothy Tetreault, who's the ESTCP Program Manager for the Installation Energy and Water Program area. Before joining ESTCP, Tim worked at the National Renewable Energy Lab, where he focused on energy efficiency and renewable energy project development for the federal sector. Tim, please proceed.
Thank you, Rula, and welcome everybody to today's SERDP and ESTCP webinar. I just have a few slides to give a background on the programs, highlight some of our upcoming webinars, and then I'll hand it back to get on with the presentation. So, SERDP is the Strategic Environmental Research and Development Program that was established in 1991 by Congress as a partnership between the Department of Defense, Department of Energy, and Environmental Protection Agency. And SERDP's mission is to identify and address high priority environmental science and technology opportunities that focus on DoD requirements. And SERDP funds both fundamental research as well as advanced technology development that ultimately impacts real-world environmental management. And ESTCP is the Environmental Security Technology Certification Program in which we demonstrate innovative environmental and energy technologies And these investments capitalize on past investments under SERDP or other research programs and are designed to transition the technologies out of the lab and into the field. And high priority is put on ultimately transitioning these technologies to implementation and regulatory acceptance. SERDP and ESTCP are complementary programs with much of SERDP research occurring in the lab and at pilot scale with an occasional field effort, while ESTCP demonstrations are primarily at the pilot and field scale, and some occasional lab efforts are associated with some ESTC projects as well. There are 4 program areas. Sorry, jumping around here. There are 4 program areas in SERDP and 5 in ESTCP. With the installation, energy, and water program area is only an ESTCP, while the other 4, environmental restoration, munitions response, resource conservation and resiliency, weapon systems and platforms, are both SERDP and ESTC programs managed jointly by a designated program manager. Our webinar today is focused on research and demonstration conducted under the Installation, Energy, and Water program area. The Installation, Energy, and Water program area is essentially 3 main areas of research: smart, secure installation energy management, efficient integrated buildings, components, and distributed generation. Our upcoming webinar series highlights research and demonstration efforts from each of the 5 program areas. Sorry, I'm jumping around here a little bit. Here, trying to get to the slide. Can you help me? Or get to this slide with the upcoming webinars? There we go. As you can see, our webinar series has a broad range of topics covering all of our program areas. Shown here is our schedule for the upcoming webinars that include approaches for PFAS sampling and treatment, advances in detection of submerged unexploded ordnance in marine environments, managing chlorinated solvents in groundwater, new resource conservation paradigms in DoD lands, and others. And our next Installation, Energy, and Water webinar will take place on Thursday, May 20th. And it's focused on advancing microgrid solutions. You can find additional information about our upcoming webinars at this link. And I would like to remind you that a copy of the presentation of today's session can be downloaded from our webinar webpage. We'd also would appreciate if you could take a few moments at the end of the presentation to complete a survey that will pop up on your screen at the end of the webcast. Thanks for joining today, and with that, I'll hand it over back to Rula.
Thank you so much, Tim. It is now my pleasure to introduce our 3 speakers. We're going to kick off with Dave Vigliotta, who is Director of Strategic Partnerships at Slipstream in Madison, Wisconsin. Dave is responsible for developing and implementing strategic business initiatives and marketing strategies that support Slipstream's education, research, policy, and programs. He recently served as a panel co-leader for the American Council for an Energy Efficient Economy. He earned a bachelor's degree in marketing from Plymouth State University in New Hampshire. Our second speaker will be Dr. Joe Joe, who is a principal engineer also at Slipstream in Madison, Wisconsin. Joe has over 25 years of experience in building controls, and his current areas of research focus on emerging technologies and product field testing and verification. Joe is a member of the American Society of Heating, Refrigerating, and Air Conditioning Engineers, referred to as ASHRAE, and also the Association of Energy Engineers. He has bachelor's, master's, and doctoral degrees, all in electrical engineering. And our third and final speaker is Mr. Guideline, who is a technical director within the Research and Technology Commercialization Group at TRC in Oakland, California. Guideline has 15 years of experience in commercial building energy efficiency and building science research. He is currently the vice chair of ASHRAE Guideline 36 Committee, and he earned a bachelor's degree in physics from UC Santa Cruz and a master's degree in architecture with a building science emphasis from UC Berkeley. Dave, please get us started with today's technical presentation.
All right, thanks, Rula. I've been on the other side of organizing several webinars and virtual trainings this past year, and I know what it takes to pull them off. So thanks again for all your work, and thanks so much to Tim as well for the invitation to be here. So again, my name is Dave Vigliotta, and I'm Director of Strategic Partnerships at Slipstream. If you're not familiar with us, we're a mission-driven nonprofit organization headquartered in Madison, Wisconsin, and we specialize in energy efficiency research, education, and programs. So I'm on our education team at Slipstream and have been designing and delivering continuing education programs for building professionals for more than 10 years now. And my colleague Joe, who you'll hear from soon, is a principal engineer on Slipstream's research and innovation team. Joe, along with several others on our project team, including the Army Corps of Engineers, Texas A&M, and TRC, were principal investigators of ESTCP advanced controls demonstration projects. So we're excited to bridge both our education and research teams to develop this new curriculum and tech transfer program for the DoD. With that, I will jump into our slides. There we go. So quickly, here's an outline of what we'll cover during the webinar. I'm going to kick things off with an introduction to the project and share our objectives. I'll then provide an overview of our project approach and the different DoD target audiences that we'll be training. I'm then going to turn it over to Joe, who will cover the next two bullets here. So he'll give an overview of the training modules and topics and provide a demo of our training resource. We'll go for about 20 minutes total and then take some questions. Then Guideline at TRC is going to take over and he'll provide an overview of ASHRAE Guideline 36, which is the new guideline from ASHRAE to standardize HVAC control sequences. We'll then take another break to answer questions. All right, so introduction to our ESTCP Advanced Building Controls Tech Transfer Project. So right off the bat, why advanced controls? Well, there have been many research and technology demonstration projects on the potential energy savings of advanced controls in the last several years. One in particular that we reference a lot is a PNNL, or Pacific Northwest National Lab study, that reports advanced controls could result in an average of nearly 30% energy savings. However, based on several ESTCP demonstration projects, the principal investigators reported a huge knowledge gap on advanced controls across the DoD. In addition, these ESTCP advanced controls projects yielded very promising results. So based on the knowledge gap, the lack of current training in the market, and the potential for significant energy and cost savings, this is a great opportunity for technology transfer. As I mentioned earlier, one of the unique things about this project is that we partnered with principal investigators of several ESTCP demonstration projects to develop this comprehensive curriculum. And lastly, we'll be disseminating these concepts and applications to multiple target audiences across the DoD, and I'll get into a little bit more on that later. So the objectives of our projects are boiled down here. Improve the understanding and awareness of advanced building controls and energy management so DoD audiences can take greater advantage of all its benefits. Increase the knowledge and competency gaps of key building control concepts. Educate DoD building managers, operators, and engineers on ASHRAE Guideline 36. Teach specific topics such as retuning and continuous commissioning using building automation systems. And finally, working with the Army Corps of Engineers to review ASHRAE Guideline 36 for potential adoption of the Unified Facilities Guide Specifications, or UFGS. So this slide illustrates our project approach. Task 1, outreach and training planning, which we completed last year, although it really has been ongoing and remains to be critically important for us. We worked with the Army Corps of Engineers to identify DoD stakeholders across military branches. We also implemented a stakeholder survey to help inform our training topics, which was very helpful to get that direct feedback from various DoD audiences. Task 2, which we completed this past fall, was developing curriculum for DoD energy managers. This consists of 5 training modules, which you can see listed here. These comprise of short 15 to 20-minute recordings on various topics within each module, and these courses are intended to be very high level and are currently available on our website, so we invite everybody to check them out. We're now in task 3 of our project, which is developing the curriculum for engineers and building operators. We'll go into much more detail on the topics, and it will consist of hour-long webinars. We'll also be offering continuing education credits for these courses. Task 4 is earmarked for the Army Corps of Engineers to review ASHRAE Guideline 36, and Task 5 is collecting feedback on our education and trainings through surveys and evaluation. So continuing with our project approach, before I turn it over to Joe, here's a snapshot of some of the tech transfer activities that we'll be offering. Although quickly, I'd like to take a moment and recognize the ESTCP Energy and Water Program for offering this technology transfer category and leading the DoD in accelerating the adoption of these advanced technologies more broadly. We spoke with dozens of stakeholders across the Army Corps of Engineers and other military branches during our outreach phase, and the message was clear that more education and trainings on these advanced technologies and topics are critical and much needed. Tech transfer is pretty unique, and I haven't really come across many other programs like this. So thanks again to ESTCP for recognizing the importance and for their leadership in this area. So circling back to this slide, it's a good overview of the education activities that will be made available. Again, stakeholder outreach has been super important for us. I also wanted to mention that we've been in contact with NIBS, the National Institute of Building Sciences, and we'll leverage their whole building design guide to expand our reach and share this curriculum across wider audiences. Other activities, education activities include forums and blogs, webinars and videos, trainings and conference presentations, fact sheets and infographics, and working to update facility standards. All right, with that, I will now turn it over to Joe, and then we'll both be available to answer questions at the first Q&A break. Joe, the floor is yours.
Thanks, Dave. My name is Joe. I'm a principal engineer. I'm going to talk about the training modules and topics and provide the link to the access the task 2 training resource. So for this project, we have 2 sets of training resources. One is targeting DoD energy managers. The content are different at different levels. For DoD managers, we have shorter sessions. Each of them are 10 to 20 minutes. We have a total of 16. These are sessions separated by 4 different modules. So the first module, Fundamentals of Building Control Systems, includes the sessions like Introduction to Building Automation System Architecture, Introduction to BACnet Longworks and Niagara, and some basics of HVAC controls, components, and control loops. So those are the 4 technical sessions in the first module. But at Advanced Control Strategy, we have 7 technical sessions, like energy savings for advanced controls, introduction to optimal scheduling, introduction to air hand unit supplier temperature and pressure resets, introduction to economizers, introduction to demand control ventilation, and 2 sessions on advanced on ASHRAE Guideline 36 high performance building control sequences. And then for the third module, energy modeling, intelligent building operations, and advanced energy performance, we have 2 technical sessions cover energy modeling 101 and smart building operations through optimal controls and energy performance monitoring. And then the 3 control-related ESTCP project is serving as an example that we have demonstrated through ESTCP project these advanced control related projects can provide cost-effective energy saving opportunities. So again, these are shorter sessions because DoD managers, they typically don't need to know the details, but it will be good for them to understand the basic concepts. So when they decide energy projects or have an impact on the control-related project, they can understand some basics, terms, concepts, and energy impact for these projects. So this sets of courses, 16 short sessions already available on our website. I'll show you the link to that website in the next few slides. Then what we're doing now, we have another set of course resources that in targeting energy engineers and facility operators. So the topic areas are similar to the training for the DoD managers, except we have provide more depth in terms of technical details. And then we also link the actual UFC and UFGS, which need to be understood to do any DoD project. You have these guidelines and the specifications that should be used on any of these control-related projects. So we integrate those guidelines and specifications into these fundamentals, advanced control strategies, modeling, and we also add another module on the building commissioning. We have invited PNL and also Texas A&M talk about retuning and continuous commissioning topics in those modules. So similar kind of technical session titles compared to the first one, but we provide much more details. These are hour-long sessions. We have a total of 22 hour-long sessions so that engineers, again, these training resources not intended that to train these engineers and facility operators to be a control contractor. Rather just let them understand the control design, control implementation project process so they can work with these control contractors, understand why they need some document, why they need doing things or specific requirements from the DoD, UFC, and UFGS. So these are training resources that should be helpful to stakeholders, specifically engineers and facility operators, to understand control projects. We're currently doing we developed the slides for 11 of the 22, and we're going to continue to develop the rest of the 11 sessions in the next few few months. Then expect the resources to be online before June 2021 in several months. So just to give you some screenshot of the task 2, which is the resources for energy managers, the 16 shorter sessions. This is just screenshots for the overview for the course. This course is hosted at the Slipstream Learning Management System, which is hosted, we use a co-assembled learning management platform. This is a screenshot of the first cover page. It just provides overview about the project, about this building controls for energy managers course. And then there's a first cover page also cover the speakers. This is me, and there are a few other speakers information on this page as well. So this is when you go to each of specific sessions. For example, this is the first technical session in the first module of fundamental building control systems. And we provide 3 things in each of these modules. One is the video. So we recorded the PowerPoint slide through speakers, and you can, about 10 to 20 minutes. Each of these sessions are slightly different in terms of length. And you can click on the play button from any website, and it will play. This just give you an introduction about building system architecture video. That's the first, that's the key components of this training resources. You give anybody a high level of introduction about fundamentals of building automation system architecture. Then, so this learning management system has a kind of, on the left side, there's a bar showing your training progress. And this is the 1.1 is the first technical session, and 1.1a is the actual video. Then follow that, there are 3 simple quiz questions, and then follow that, 1.13 is a survey. Then is the next session is about BACnet Longworks and Niagara framework. That's 1.2. That's another 3 components in a technical session. So this left side bar of this on the learning management system can record how far you have gone through, how many quiz you have checked or videos you have watched. So this is a system that record your just training progress. This is an example of the quiz, one of the 3 quiz questions. Again, this for the training managers for 15 short minutes. These are just a quiz, just to enforce learning. We don't provide any like professional development hour. That will be provided in the task 3 for engineer hour-long session. These are just shorter session to introduce those concepts. So some of the quiz should enforce the target audience learning, understanding of the material. And then at the 3rd components of each of the technical session is the survey. We want to know whether you feel it's useful, and how you rate this session. Is it good or excellent or fair? So it's embedded in this learning management system. Then you can download the PowerPoint slides for these training sessions by modules. So we combine the first module, which is the fundamental of building control system courses, which consists of 4 sessions, into one PDF file. You can click on this and download and read that later if you don't have time to watch the video. And this learning management system also is portable device compatible, so you can watch it on your smartphone. And this is just some screenshots of how it looks like on your smartphone. You still need to, there's no app, but you still need to just type the address for this training course, which we'll provide in the next few slides. But you can see it. This is a vertical view for on your cell phone or smartphone. I use the iPhone to record this screenshots. And then you can also, it's a horizontal view. If you actually want to watch the videos, it's probably not good to use a vertical view. So it's a horizontal view. You can just click on the expand the symbol. It will just like you watch a movie on your smartphone. You don't have to use a computer to access the training resources. It's just easier for some audiences. If they don't have time to go to the computer, you can watch the training resources on your smartphone. So here's the key part. The resource for the task 2 already been hosted as Slipstream Learning Management System, which we use a company's platform called CoAssemble, but you need to do a one-time registration at this link. It's a very simple, just provide you your kind of name and email address and create it one time, and then you can use that to access all the sessions, and including the future sessions for task 3, hour-long sessions ones. And then once you register, you can you need to confirm your email address. Then you can access the Slipstream LMS platform through this link, ESTCP-slipstream.coassemble.com. You should Currently, there just one course is the Task 2 for DoD managers, Advanced Control Training course for DoD managers. In around June, we should have the Task 3, which is the training courses for DoD engineer and facility staff as well. And that's all I have. Any questions?
Great. Thank you so much, Dave and Joe. This is really fascinating work. We got a whole lot of questions from the Army Corps and from other organizations asking for the hyperlinks to the training material. So I would like to remind everyone that the PDF of the slides is available on the SERDP and ESTCP webinar webpage for this project. So if you go to the webinar webpage, click on the link for this webinar and download a PDF of the slides. All the hyperlinks are available on slide 36. So with that said, let's go ahead and start with other questions that have come in for you, Dave and Joe. We'll start with Dave, and Joe, feel free to weigh in. Can you provide additional information about the continuing education credits that you are offering through this training?
Sure. So we'll be offering professional development hours, or PDHs, for the Task 3 engineers and building operators. So potentially up to 21 professional development hours will be offered. We're also going to offer AIA credits and GBCI through the USGBC for some of those courses that we're currently developing. You know, if it's applicable to those accreditations, we'll apply for it. But those are the three primary ones, so PDH, AIA, and GBCI.
Wonderful, thank you. And this is a question for Joe from Arizona State University. You mentioned that the training resources are available for ESTCP energy managers and stakeholders, but are they available for free to researchers and performers of other ESTCP projects?
Well, actually, this resource is free to general public. Anybody can sign in and access the resources for free. I want to emphasize the DoD managers and engineers, because this is a DoD-funded project. We do have some metrics we need to meet to see how many DoD folks viewed and complete those sessions. So I emphasize that. But the actual resource is open and free to anybody who wants to sign up.
Thank you, Joe. Another question for you and Dave, and we'll start with you, Joe. Are you planning on sharing information about this project at any other DoD workshops or events outside of the online curriculum?
Yeah, so during the stakeholder outreach phase that I mentioned, you know, we identified several conferences and workshops to deliver the trainings. And some of those included the DOE Energy Exchange, which Joe presented and served on the conference planning committee. There's a REM Resource Efficiency Manager workshop that we're in contact with to potentially present at this spring. Also working with our project partner, the Army Corps of Engineers, on a retro commissioning workshop that they host frequently. We've also been in contact with IMCOM. So there's, yeah, several different conferences and presentations. And again, I mentioned NIBS and the Whole Building Design Guide. That's another opportunity for us to share this resource with a wider audience.
Thank you, Dave. This is a question from Spectrum Solutions, and maybe Joe, you can take a crack at it. Are the courses, the online courses, are they going to be facilitated by live personnel? And will you be providing any physical resource materials beyond your final research, ESTCP research report?
For these training, again, as Dave said, the online training is so anybody can sign up and watch those videos. And then for some of the conferences, we do plan to present some of these tech sessions. And we're still trying to finalize at which conference, either a virtual conference or in-person conference, we're going to do that. In terms of the slides, you can download them, the actual slide, you can download them once you sign in and access the course. And feel free to send out any other questions. The project team can answer them. But for now, the resources are just the online videos and those questions and the PDF files for the presentation slide you can download. And for task 3, I think once you watch those, we'll provide professional development hours, but there will not be like in-person, like live question or answers planned yet for these resources. So probably watch out for this is Energy Exchange and the ESTCP Symposium. We present a short about this project for about 20 minutes. Maybe next year, if we develop all these resources, we can schedule some of these interested sessions to be presented on next year's symposium as well.
Thank you. Joe, are you planning on sending any notifications out to a mailing list of some sort when the training does become available in June? How can people know when the training will be posted?
Yeah, so we plan to, we do have our connection at Army Corps of Engineers, at Air Force, and at Navy. So we're planning to use our network to let them know and they have access to their network of energy managers. We'll let them know the resources available, and through ESTCP probably as well, like the opportunity like this and probably future opportunities that we can, we'll reach out to wider audience and we'll post it potentially on ESTCP website and other outreach effort. We can reach out to hopefully most of the energy managers and facility engineer at DoD.
Yeah, and as I mentioned, we're also going to work with NIBS, the National Institute of Building Sciences, on outreach and collaborating on a webinar, maybe similar to this, where we would provide an overview of the project and then go into a little bit deeper detail on a specific course topic through the whole building design guide.
Yeah, so I want to add on that. We're currently talking to NIBS to see potentially if this course will be included as one of their catalogs in their training course. We understand a majority of the federal employees using WBDG website as a central resource for all these trainings. And it could easily just move our video, these content to NIBS WBDG website, so you have a central place to get all these resources. So we're going to talk to ESTCP and talk to NIBS to see if that's a possibility in the future.
Great. Thank you both. We're going to conclude with one quick question for you, and we'll get back to any unanswered questions during the final Q&A. So before we transition to Guideline, can you let us know if these sessions are DoD specific, or do you expect them to include discussions, more generic discussions about controls, control projects, and advanced control strategies? Joe?
Yes. So for task 2 is more generic because it's very high level discussion about fundamentals, controls, and benefits. But for task 3 is very specific to DoD project. We try to incorporate a lot of the requirement from UFC and UFGS. So I would say if you want to learn DoD specific control related information, go to the task 3 resources. But if you want to just learn in general a high level concept or terms or basics, you can just watch the task 2, the shorter version of it.
Great. Thank you, Joe, and thank you, Dave. And at this point, Guideline, the floor is yours.
Thank you, everyone. I'm really glad to be here to talk to you about ASHRAE Guideline 36. Still trying to get control of the screen. Looks like I have it now. Go back to the outline. There we go. So I'm going to tell you what this guideline is all about, and describe why it was created and what the anticipated benefits are, and then get into some grant-funded field demonstration and market development activities. I actually won't be touching on the HVAC and lighting integration. Those slides didn't make it into this deck. So the guideline's titled High Performance Sequences of Operation for HVAC Systems. It was developed by an ASHRAE committee, and we introduced ASHRAE previously. It contains narrative descriptions of building automation system control logic. And the guideline is really based on industry best practice control sequences that have been developed. It's been developed over many years with input from controls manufacturers, specifying engineers, commissioning agents, and many others. The committee that developed it uses an ANSI certified open process, which includes open meetings, lots of stakeholder input, and this guideline ended up going through many rounds of public review before it was published. It was first published in 2018, and the committee that generated it has now transitioned to a continuous improvement model and is working on future updates and addenda. So here's a quick summary of the contents of the guideline. I'll go over this fairly briefly, but you can actually find a lot more detail in one of the 15-minute trainings that Joe and David just mentioned. There's one called Introduction to Guideline 36 that dives into all these topics. So the guideline's meant to provide uniform best-in-class control sequences. The current scope currently covers air-side HVAC systems for VAV reheat, single zone, and dual fan, dual duct systems. The wet side controls, so that would be controls for boilers and chiller plants, are coming in the near future. They're actually being worked on right now. And then some of the key features are in the bullets there. Some of the key features of the sequences are listed. I'll just touch on a few of them. At the zone level for VAV zones, the zone logic is designed to minimize reheat and also prevent overcooling. And this the zone logic is often called dual maximum logic. And I'll talk about this a little bit more in the subsequent slides. There are demand-based resets for adjusting central air handler set points based on zone demand. And this is a significant energy saving measure. This is where a central air handler actually continually adjusts its supply pressure and temperature to just barely satisfy the most demanding zones, thereby minimizing energy consumption while also ensuring comfort and ventilation requirements are met. And then out of those others, one important one is hierarchical alarm suppression that ends up dramatically reducing the frequency of alarms and helps building operators prioritize their activities. So this slide here is just the title, purpose, and scope of the guideline. This is what governs the development of it. I've already told you the title. The purpose is to provide uniform sequences of operation for HVAC systems that maximize HVAC system energy efficiency and performance, provide control stability, and allow for real-time fault detection and diagnostics. The scope covers the detailed sequences of operation for HVAC systems and the functional test to confirm implementation of those sequences of operation. So currently, the published content of the 2018 standard is written in the format that you would typically see in a control specification. So this it includes detailed sequences of operation, lists of hardwired points, and control logic diagrams. The current published standard or guideline does not have the functional tests that are listed here, and that'll be coming in future addenda. So the current control industry approach for programming control logic is really suboptimal. Each building is essentially a customized ad hoc process that often introduces bugs, and the performance on day one is suboptimal, and it can get worse over time as band-aids are put on the control logic. So Guideline 36 provides standardized sequences that are also high performance, that are well vetted from a variety of stakeholders. And this diagram is summarizing the anticipated benefits from various market actors. We definitely anticipate energy savings and measured some of those. I'll go into that in a minute. When it comes to implementing controls retrofit projects, across the board, various stakeholders should see reduced level of effort and cost for controls retrofits, because at some point you should be able to cut and paste some standard libraries. There's a lot of potential for occupant comfort benefits, fewer complaints, improved thermal comfort. I'll talk about that a little more. Building operations should improve, clearly with standardization and consistency. It's easier to manage buildings. It's also, if you have improved quality, the buildings just run better. And then finally, there's potential for increased volume of controls retrofit activity if we can make the business case for upgrading older buildings that have somewhat outdated controls. So let's get into some of these, some of the research that supports these benefits, anticipated benefits I'm talked about in the last slide. I'm going to start off with a summary of research that occurred actually before the guideline was published that helped motivate the generation of the guideline and some of its content. And then I'll get into some ongoing research projects that are demonstrating, doing pilot projects of Guideline 36 in the field. So the first project here is a county office building, 555 Sid County Center. This was a case study by Taylor Engineering. The existing building had fairly outdated digital controls throughout, all the way to the zone level, that was fully upgraded. So every controller in the building was brought up to, was replaced with new control hardware. And then the sequences were programmed similar to Guideline 36. It was actually before the guideline was published, so it's not exactly the same, but it's very, very similar. And the measured weather normalized whole building energy savings at the utility meter was 15% electricity savings and 56% natural gas savings. And this resulted in a 6.7-year payback for the full control hardware retrofit. And the significance of this case study is the short payback, essentially. I mean, the savings were deep, but the short payback is counter to what most people believe about controls retrofits. Most people in our industry believe that a full controls retrofit of all the hardware will not pay back on energy alone. And for this reason, a lot of existing buildings actually don't replace zone controllers when they upgrade. You may upgrade the central plant, the air handlers and chillers, the central equipment, but then leave the zone controls in place. Even pneumatic zone controls are still in place in many buildings because it's considered to be not cost effective to upgrade them. The second project here was an ASHRAE sponsored project called RP 1515. It intervened in 7 buildings in a corporate campus. This was actually just control sequences, just reprogramming. The existing buildings had relatively new controllers that could be reprogrammed. And the sequences that were programmed were just partial Guideline 36. It actually focused on the zone sequences. And out of these 7 buildings, the measured savings was in the 10 to 30% of HVAC savings. And a fast, less than 1 year payback. And the reason for the fast payback is that the first costs are relatively low for simply just reprogramming. There was no hardware upgrades. And then finally, there have been quite a few published peer-reviewed simulation studies of various kinds of controls opportunities that show up to about 30% whole building energy savings. This was mentioned earlier by Joe and David for controls, advanced control sequences, such as the ones in Guideline 36. So the ASHRAE 7 building study also uncovered a significant cause of overcooling and comfort overcooling that's reported in detail in this ASHRAE journal article from last year. So as I mentioned, those 7 buildings, the RP 1515 project focused on the zone controller sequences. It implemented the dual maximum sequences that I mentioned. And one of the main features of the dual maximum sequence is that they allow the airflow set point to drop down to the ventilation rate between heating and cooling. So at the zone level, when you're not in heating and cooling, you drop the airflow down to a minimum required ventilation for health reasons. This is in contrast to conventional sequences that actually have a much higher minimum usually programmed. And as I already mentioned, the payback was really good on energy. The somewhat surprising, not anticipated other result of this research project was that overcooling was drastically decreased. The amount of cold discomfort reported on occupant surveys dropped by half during the summer months. And the reason for this is that the zone temperatures were warmer. They increased by about 2 degrees Fahrenheit on average. So you can reference the article for getting a full explanation of why conventional VAV control sequences end up leading to subcooled zones. So now I'll transition to talking about the current ongoing demonstration and market development work to support Guideline 36 adoption in the market. There are 2 projects that we're currently engaged in, one sponsored by the California Energy Commission and another sponsored by NYSERDA in New York. The icons across this slide here describe the scope of work for these projects. Is fairly similar between the 2 grants. We're doing demonstrations in pilot buildings. There are 2 types of pilots. One is a full hardware upgrade, so that's all the controllers, including the zone controllers, being upgraded and then reprogramming the sequences to Guideline 36. And then the second type is the sequence only, or what we call software only, where the existing building has control hardware that's capable of Guideline 36 and we simply reprogram them. All these buildings are going through very detailed measurement and verification, getting feedback from all the stakeholders on lessons learned. And then this is all feeding into market development activities. We're developing tools and resources. And in particular, we're engaging with the BAS industry, so that's building automation system industry, to change and adjust their processes around Guideline 36. So there are 11 demonstration sites in total. 7 of these sites are in California, shown here. These California sites range in size from 34,000 to 250,000 square feet. They're in university and healthcare buildings. The space types are office, outpatient medical office buildings, and classrooms across a variety of climate zones. You can see on the bottom left there that says Pleasanton Data Center and offices. We're not intervening in the data center there. It's just the office portion of the building that supports the data center. Across the top there, circled in green, are the 4 sites that will be the full retrofit of hardware plus software, hardware plus Guideline 36 sequences. And then the 3 sites across the bottom are the 3 software only or sequences only. The New York sites, sponsored by NYSERDA, are actually still being selected. We're very close. They're likely to be university buildings with a mix of administrative office and classroom spaces. And 2 of them will be hardware and software, full retrofit, and 2 of them will be software only. So this graphic here is not meant to be fully readable. This is just telling you the status of the field demonstrations in California. As you can see, we're not fully done. There's only a few of them that are in the final commissioning and reporting, measurement, and verification phase. And because of this, I'll only be able to give you results for a few of the projects, not all of them. I will show you some links or the names of the projects so that when the full results are released, you'll be able to look them up. So looking at one project in particular, this is a medical office building in Vallejo, California. It's 215,000 square feet. The existing building had pneumatic zones, pneumatic controllers in all the zones, and older digital controls at the central equipment. And everything has been replaced with new DDCs, or direct digital control zone controllers, reprogrammed with Guideline 36 sequences. This building is served by a central plant with chilled water and hot water service. So I'll be able to show you these energy results in terms of electricity, chilled water, and hot water. So I'll orient you to this chart because I'm showing it on a couple the subsequent slides. Along the bottom there in blue is the timeline. So there's the baseline period up until the start of the retrofit, then the retrofit period, including commissioning, and then the post-retrofit period moving to the right. So going up to the lines on the chart, the blue line there is measured energy use during the baseline period before we started. And then as soon as the retrofit starts, the blue line going out to the right is a modeled extrapolated energy use that would have occurred in a business as usual case. So that's as if we had not done anything to the building. That's the projected energy use that would have happened in a business as usual. And then the green line becomes the actual measured energy use. So as the retrofit occurred, the measured energy use decreased below the business as usual. And you can see that in the post-retrofit period, the measured energy use is pretty stable and flat, doesn't vary a lot. So the difference between the measured use and the projected business as usual is the energy savings. And this is whole building electricity, so it represents the fan energy savings at the air handlers. Fairly good savings, and also fairly consistent throughout the year. Now I'll switch to chilled water energy savings. So once again, during the retrofit and commissioning, the savings increases. In the post-retrofit, we're seeing chilled water savings year-round, with some more, higher savings during the warmer months, as we would expect. This is the hot water savings. So a couple things to note here. One is that the savings is large, and that's to be expected because conventional sequences, particularly with pneumatic controls, end up wasting a large amount of reheat energy. We saw the same thing in that county office building example. The other is that there are savings year-round. Their savings is definitely larger in the colder months, but there is still significant savings in the warm month, and that's really for the same reason, that there's reheat that's used even when you don't necessarily need heating in the building. So these three charts I've shown you are actually they show us avoided energy use over time, but they don't necessarily show us, or they're not good for telling us the annualized total energy savings. And so for that, I'm going to point you towards this table here that summarizes the project I just mentioned. I went through those three charts. That's actually the top line in this table, and then there's two other demonstration projects here. And the calculation approach for the HVAC savings column here is a weather normalized annualized savings prediction. So this is annual savings for a typical meteorological weather year. So that Vallejo Medical Office building that we've been talking about, the annual HVAC savings for electricity was 78%, 40% for chilled water, and 61% for hot water. The first cost, going over the third column there, is quite high. This was a $1.7 million project. The reason is they were replacing all the hardware down to the zone level, ripping out the old pneumatic zone controllers and putting in new digital controllers. But that said, the simple payback for this project ended up around 8 years. So similar to that county office building example I showed previously. Then going down to the next two rows here, these are projects that were the reprogramming only type. The simple payback for them came out at 10 years and 3 years. First cost was much lower. I'm looking at the energy savings for these. It's a bit lower. I'm not going to read off all the numbers there, but we do notice that some anomalies in some ways. The hot water savings in the Contra Costa Community College building was fairly low, and the chilled water savings in the Pleasanton Data Center offices was non-existent. And this is an important finding. It really points to the fact that results will vary and that the existing conditions are important. Control sequences in existing buildings can vary a lot in terms of their programming. And as I stated, these were already digital controls, and so they had some existing programming in before we started, and we came in and changed it to Guideline 36. So that's part of the explanation here. Another explanation is actually just coming in. These are preliminary results. They're almost final, but not totally complete. On the Contra Costa Community College admin building, the new sequence of operation had an optimal start logic, which basically the control system learns when it should turn the building on to be comfortable at the beginning of occupancy. So it was set up to make the building comfortable at 7 a.m. Well, the building operator, after the handover of the building, didn't fully understand that this sequence was in place and did what he typically does and said, I want the building to come on at 5 a.m. so that it's comfortable at 7 a.m. So a lot of operators just arbitrarily set the turn on time for a building, hoping and knowing that it will be comfortable by occupancy. But the combination of these two made the optimal start was still in place, and it tried to make the building comfortable by 5 a.m. So we ended up with a couple extra hours of building warm-up operation, which is likely a reason why we didn't see much hot water savings, and we're actually continuing to analyze that. It's a little hard to do M&V during a pandemic, though, I have to say, with low occupancy. So in conclusion, there's 3 projects here. These results may change a little bit in the final report because they're still being analyzed. There will be the 11 buildings eventually, and I've put the names of the 2 grant-funded projects there at the bottom so that you can find those resources in the future when they're fully published. So now I'm going to transition a little bit to the market development activities, the things that we're doing to accelerate market adoption. So what the main goal, one of our huge goals is to get standardized libraries. We hope that each building automation system manufacturer will create a standardized application library that's based on Guideline 36, and then it'll be third-party validated. The manufacturers would then distribute the library to their dealer network. So this graphic illustrates the reduction in effort that would occur if the pre-vetted logic was available. So across all the stages, design, construction, commissioning, we anticipate a reduction in the level of effort. The business as usual case, the current controls delivery approach is represented in light gray or light blue there, depending on your screen. And then the dark gray or dark blue is the anticipated reduction in level of effort once there are standard application libraries available. So there's savings across all the steps except for the hardware design and install step. Guideline 36 does not affect or improve the actual hardware installation at all. So we've been working with manufacturers. Many of them or most of them are actually members of or engaged with the Guideline 36 committee. They've actually started the effort of programming the standard libraries, but they're fairly slow to change, and there are quite a few barriers. One of the most significant barriers is that the dealers or the controls contractors are not used to using factory application libraries and are frankly fairly skeptical or ambivalent to do that. So there's a little bit of a chicken and egg problem. We've been tracking what the controls manufacturer's interest is and their progress towards creating these libraries. That's represented in this chart here. This is a snapshot in time and it's a moving target. But just to summarize, most of the large controls manufacturers listed on the left there have publicly stated that they have an interest in creating libraries. Many of them have publicly stated that the libraries are in development, but only a couple, at the time of this chart, ALC and Train, have actually released any libraries, and what they've released is actually just a partial set of Guideline 36, not the full Guideline 36. There's still a little ways to go to get to full libraries. I can say that since we created this graphic, Schneider Electric has released some partial libraries also. So in conclusion and summary, I've shown how standardization can lead to benefits across various stakeholders in the HVAC industry. Shown that there are measured verified energy savings up to 30%, potential for 3 to 10 year simple payback on energy alone. The BIS manufacturers are creating these libraries, and we hope there'll be some full libraries available soon, and that there's anticipated a decrease in cost and level of effort with a streamlined, we hope, kind of drag and drop process for controls retrofits. This is my last slide, summarizing some anticipated benefits to DoD. The Guideline 36 controls apply widely across lots of DoD buildings and most buildings in North America, because VAV reheat is the predominant HVAC system type. So there's potential for retrofits in these buildings. We've shown the good energy payback. We hope this can support, or I think it's likely to support, some building automation system modernization, particularly for buildings that have still have pneumatic zone controls, but also for others. And then the standardization can definitely improve facility operations, particularly when you have large sites and portfolios where you can have standardized training and knowledge about how buildings are operating. So that's it. Thank you. I'm not sure if I was going to go through this acknowledgement slide, but this is...
Hey, Gwilyn, this is Dave.
Ahead.
I can kind of take it here. If you want to just continue to keep the reins of the slide deck, I can mention the team here. So, you know, developing this new curriculum has definitely been a team effort. So quick shout out to my colleagues, Kevin Frost at Slipstream, along with Ben Bartling, who is not pictured here. In addition, I'll mention Lana Berg on our team, on our education team's been putting in a lot of work behind the scenes, implementing our learning management system, and will also spearhead our continuing education credits that we'll be pursuing. Of course, Joe and Gwilyn are instrumental to the project. Also mention Gwilyn's colleague Rupam at TRC, and others on our project team, Zheng O'Neill at Texas A&M, Brian Clark at the Army Corps of Engineers, along with his colleagues, Chris Battisti and Irene Anzigar. And you can see there's also working with several other guest speakers and subject matter experts on topics such as cybersecurity to help fill in any gaps that we have. So thanks again to everybody on our team. I think you can move to the next slide, Gwilyn. And more information on our project can be found on the ESTCP webpage by following this link here. And I believe the next slide has our contact information, or nope, there it is below. So you can see our contact information. Please don't hesitate to reach out if you have any questions. And yeah, in general, we just hope that everyone takes advantage of this tremendous resource offered by the DoD. So thanks again, everybody, for tuning in. I think we'll now take some questions.
Thank you, Dave. Yep, and now we have a number of questions that have come in for Gwilyn, and depending on the amount of time we have, we'll go back to Dave and Joe and answer additional questions. So we're going to start with a question that came in from Appalachian State University, and it is for Gwilyn. Can you speak to what kind of issues have occurred when you implemented ASHRAE Guideline 36 in your case studies?
That's a great question. We do have a long list of issues that have occurred. One of our challenges has been the installing contractor or the dealer that's not used to programming sequences that are this complicated. If they're starting from scratch, there's some resistance, they make some mistakes. We have been able to address all of the issues in their programming through the commissioning process, but it does speak to some of the challenges of market adoption if we're actually asking every individual contractor to program this ASHRAE guideline from scratch, and supports the assertion that the BAS manufacturers should be creating application libraries for all of their dealers around the world.
Thank you, Gwellen. And this next question is from Lockheed Martin. Do you have any comments on how the ASHRAE Guideline 36 has been impacted by COVID-19 pandemic responses, like increases in fresh air?
Absolutely. Yes, thank you. That's a fantastic question. There are elements of ASHRAE Guideline 36 related to ventilation, demand-controlled ventilation, outside air minimums, zone minimums, etc. And all of those have been called into question to some degree or other with pandemic response recommendations from ASHRAE and from other organizations. So the control sequences still work, but I think the main point is perhaps the set points need to be increased for increased ventilation. With that regard, the Guideline Committee is actually considering and probably will adopt a new mode of operation. So for HVAC systems, there's often the occupied mode, setback mode, unoccupied mode, things like that. And there's now a proposal in the works, a discussion around a pandemic mode that would actually sort of be pre-configured, kind of like a demand response event that you could actually change one setting and then all of the controls would respond.
Thank you so much, Gwellen. This next question is from Wood. Were additional maintenance costs, if any, considered as part of the energy and cost savings?
Sure. So when it comes to additional maintenance, the intervention that we're doing is focused on the logic, the control logic. And in general, we've seen that with really well vetted debug control logic, there is a reduction in the amount of maintenance that's needed to maintain the programming in the building. Often controls contractors are called upon to reprogram buildings when things go wrong or seasonally, and that's often because not everything was thought out ahead of time. That said, we have not tried to document how much reduction in maintenance efforts occur. So secondarily, there are elements of Guideline 36 for fault detection and diagnostics and alarming that support a building operator in their typical maintenance activities, addressing things that are broken, for example, and comfort complaints, et cetera, in the building. And once again, we anticipate that the Guideline 36 approach makes it more efficient for the building operator and maintenance staff to do their job. But sorry to say that we're not documenting that. And I really think we actually need larger scale penetration, more case studies to get the level of data we'd need to answer that question with hard data.
Thank you, Gwellen. Here's another question. For campuses that either have some remaining pneumatics and or an exclusive building automation system provider that has not released a library yet, what can we do to ensure we're working towards eventually adopting ASHRAE Guideline 36?
It's a fantastic question. We know of a number of campuses and some corporate portfolio owners that have standardized on Guideline 36. They're really the early adopters. There aren't a lot, but they've taken a couple approaches. One of them is to simply reference Guideline 36 in your master specs or RFPs, and that compels the design engineer, consulting engineer to use the guideline and they're developing when they develop the control sequences, or if you're doing design build, it compels the installing contractor to use the guideline. The second approach that we've also seen is to actually adopt or use the content of the guideline. As I said, the guideline's written in the same way as a typical specification, and so you can cut and paste the text into your spec. And I know of one community college district that actually hired a consultant to update their master spec with Guideline 36. And they've been using that. Both of those owners that I'm thinking of have been mostly focusing on new construction. That's quite easy. Retrofits are a little bit harder. You'll end up with nuances and customization related to existing conditions in the building and the existing controls. And so you do kind of rely on your consultant and design teams to figure out how to implement Guideline 36 most efficiently.
Thank you, Gwendolyn. This next question is from McCool Controls and Engineering. Is in a scenario where one terminal VAV or variable air volume zone is modulated to a minimum flow equal to the required ventilation rate, doesn't the whole air handling unit then have to be on 100% outside air? Does this possibly result in higher energy costs overall?
That's a good question. I think I understand the question. The concern is around what happens at the air handler when the zones are ramping down to minimum, or lots of zones are at minimum. And the answer is that the Guideline 36 control sequences are also continually resetting the outside air intake at the air handler. So the air handler outside air intake is based on the zone demand. If there are zones that are in unoccupied mode, they don't necessarily need ventilation, and the air handler will reduce the outside air intake. When it comes to the minimum that's delivered to the zones, I mean, we need to meet code, and which is often based on ASHRAE standard 62.1 for ventilation rates. You have to deliver that outside air to those spaces. So in the event that the building is completely turned down everywhere, you do end up in situations where the
It looks like we lost Gwendolyn. So I would like to suggest that we go back to to the other general questions until Gwendolyn rejoins. So Dave and Joe, I have a few more questions that we didn't get to.
I'm actually back again. I'm sorry for a battery loss, so I'm switching my headset battery, and I can still be here for future questions, but after.
Excellent, excellent. Why don't you wrap up your response to this one question, and then I'll relay the question to Joe and Dave from Fort Bliss.
Can you tell?
Are you okay doing that?
Yeah. Can you tell me where I dropped off? Sorry.
I was too busy panicking.
So right. So we were talking. Really so I will just jump in. I was responding to outside air intake at the air handler responding to zones. I'll just quickly summarize that it's dynamic. The outside air intake is reset based on zone demand.
Thank you so much, Gwellen. Joe, this is specifically a question from Fort Bliss, and they have a contractor who maintains their HVAC, but zero retuning is in the actual contract. Are you, through your training program, able to provide retuning certificates for these contractors? Is that a possibility?
So I cannot answer that question for you. Unfortunately, we invited speakers from PNNL to have one technical session for our task 3. So we have not recorded that video yet. Specifically, question either retuning or continuous commissioning. I think the speaker will have high-level discussion. I don't know that our training resource will cover many detailed training methods, but they cover the concept, and actually PNNL have a very comprehensive retuning course. So our purpose in this process is just to discuss the basic fundamentals, what is retuning or continuous commissioning, and then they will provide more resources for more comprehensive training from other places like PNNL or Texas A&M. So again, I cannot answer your specific question on the certification or retuning. That's the question probably for PNNL's guest speakers. I can, if you can send me an email, I can get back to you once I contact the guest speaker.
That would be really useful, Joe. I'll forward you specifically the information for the Fort Bliss CSC, and you can follow up with him directly. Thank you so much for offering to do this.
Okay.
This next question is also for you and for Dave, and it's from Daywat. Will the training give examples of popular and reliable energy management system controllers, sensors, and other devices? That's because the author of the question is noting that the choices of manufacturers can be overwhelming. So will you be providing guidance in this area that would be helpful to the Department of Defense?
Yeah, so in the task 3 session, we're going to touch on those questions. But specifically, we won't promote or advocate any specific manufacturer's product. And actually, DoD's requirements on the control system is you have to be open system. So which means any project you cannot tie it into a specific contractor or manufacturer. Actually, they require all the system, either BACnet or Longworks or Niagara framework, which most of the building control manufacturers now have products or components of it is compatible with those protocols. If you don't do that, you are not you cannot be selected for DoD project. So again, we'll provide some examples of those sensors or actuator or control component, but we don't. The only guidance I think in our course will cover is you have to select open system. We do discuss a lot on the UFC and Unified Facility Criteria and Unified Facility Guide specifications that on the requirements for the DoD project. Again, most of DoD projects require very general open protocols. So we can probably provide some examples of the product, but we don't mention specific features or technology regarding to the manufacturer product. We just only suggest you have to comply with specific open protocols. Thank you,
Joe. All right, we're gonna, we have time for 2 more questions. So this next one is for Gwellen, and then the last one, I think all 3 of you can answer. So Gwellen, this is from Turntide Technologies. How can we expect DoD managers to get access to the ASHRAE Guideline 36 and decrease skepticism about adoption. Do you have any thoughts on this topic?
Well, in terms of accessing the guideline itself, it's for purchase from ASHRAE. So that's the way to get it. There is, we worked with ASHRAE on the copyright and licensing agreement so that it's actually different than most other ASHRAE standards and guidelines in that reproduction and reuse of the content is allowed. So once you have the guideline, you can cut and paste the control sequences verbatim into your control specifications or master specs. In addition, there are many resources, conference presentations, 4-hour trainings, etc., that are available online in various shapes and forms, many of them free. And like we said, there are 2 different 15-minute or 10 to 15-minute trainings that are part of this training that's live on the website right now, and we will have 2-hour-long sessions that will be added in the task 3 in the future.
Great, thank you so much. And last question, and this is for all 3 of you, but I'd like to start with Dave. How can one find more information about ESTCP Advanced Controls demonstration projects? Dave?
Sure. So we're going to be providing links to each of the demonstration projects on our training webpage. And then in addition, we developed fact sheets for each of those projects, which are currently under review by ESTCP. We hope to get that back soon. And those are also going to be available on our training webpage. Also, you can go on to the ESTCP website, and I believe if you plug in the project number or more information on the project that we shared in the presentation here, you should be able to access the final reports for each of those projects.
And I want to add that in this tech transfer project, we covered 3 or 4 previously completed ESTCP projects related to advanced controls and management. There are other ESTCP projects that are related to control and other areas as well as not covered in this tech transfer project. You can still search from ESTCP website under the Energy Installation, Energy and Water program. There's a list of all these controls all these projects. You can look at the completed project. You can look at the title and see anything that relates to advanced controls. You can then download the report from there as well.
Great, thank you so much. Gwendolyn, anything to add?
No, I just thank everybody for attending today.
Great. Thank you to our 3 great speakers today. Before we wrap up, I'd like to remind you that our next webinar is on Thursday, the 28th, and it is in the Environmental Restoration Program area. This webinar will focus on DoD-funded research efforts to improve both the screening and the treatment of PFAS. We will have 2 speakers, Dr. Graham Peasley from the University of Notre Dame and Dr. Linda Lee from Purdue University. Registration is open, so please visit the SERDP and ESTCP webinar webpage to register for this and other future webinars. And as Tim mentioned earlier, the next EW webinar is in May, so feel free to register for that also. Before we conclude, I'd like to remind you that both the audio and a copy of the presentation of today's session will be archived on the webinar webpage in case you would like to refer to them in the future. We would appreciate it at this time if you can please take a moment to complete the short survey that will pop up on your screen. This concludes today's webcast. Thank you so much for your attention.